We just want to be the best at what we do, and we don't engage in any program, be it Formula One or the production of the McLaren 12C, unless we can realistically expect to be the best in the world.
If you built a Formula One car and you wanted it to go as quick as it possibly could with massive amounts of horsepower, these are the trick bits you'd put on a Formula One car.
It's British engineering at its best. We are taking on the world's sports cars.
Formula One has the most technically advanced gadgets. You know, it's like NASA of motorsport.
I think NASA would compare themselves to us, to be quite honest.
Temperatures coming out of the exhaust are approximately about 800 degrees, so we've seen problems with the bumpers melting before.
To actually be here looking at the car like this at this stage of the program is unheard of. This is almost as if it's in the womb of the mother. Not even the doctor has seen it yet.
This is a dirty job, but somebody's got to do it. Heavy most of the time, hot some of the time.
It's more than just one person's dream. This holds really the future key to 800 jobs in automotive. There's a lot riding on this working.
Hidden amongst the Surrey countryside lies a building like no other. The glass and steel structure is the brainchild of both the architect and one of Britain's best automotive engineers, McLaren boss Ron Dennis.
Lots of people visit this facility and sort of cross-reference to a sort of Bond film or something. I haven't quite had a stuffed white cat presented to me to stroke at my desk, but I mean, those comparisons have been drawn. Is that such a bad thing, though? You know, I mean, what's being portrayed is someone who's clearly looking to have an incredible environment in which to take on the world.
And is an environment where every detail is thoroughly thought through. Ron is obsessed with perfection.
So here there's a broken tile. Most people will be annoyed and just, as I am, thinking, oh, it's a broken tile. But the reality is that when it's changed, it will be in perfection, because effectively the colour won't match. It's impossible. Tiles come in batches, therefore you can see here this one's been changed. Doesn't that bug you? It bugs me. Big time.
It's 7:30 a.m. and one of McLaren's newest recruits is on her way to work.
My name's Rachel. I'm 19 and I'm currently a trainee at McLaren. So after I've done that, then I'll become a full-time production member. There's the big McLaren sign there, which is lit up red when either Jenson or Lewis wins at a Grand Prix.
Rachel Melvin is an apprentice production engineer.
It really does look like a Batcave entrance with the spiral staircase going down. You can't really see anything until you get back up inside the building. This is not really a general entrance corridor like any other building would have. I thought at first it looked like Charlie and the Chocolate Factory. You know, when they've got that massive white door that just goes into nowhere.
There's no question in my mind that you are being mentally decluttered, and it's a cleansing experience. You are stimulated by the whiteness. I think there's a slightly sterile feel, but it's a small price to pay for someone coming into the building and then having the impact of all the colour that comes as a result of the products that we make.
Comfy trainers off, big clumpy work boots on. Not really a girly type shoe, but have to put up with it. It really is a maze, it's unbelievable. Unless you know where you're going, you'll definitely get lost. If you look at these two sides, you can see that side is exactly the same as that side.
It's very easy to look at things in this building and suddenly question what anal mind is behind it and what is the thinking behind it. Of course, it's very apparent that it's very clean. It's less apparent that it is odourless. It is also a constant temperature. We hold the whole building within 1 degree of 22 degrees. There's no clutter in this building. Cluttered building, cluttered mind. It's the attention to detail that I'm really quite well known for.
And in his search for perfection, Ron hopes the building's message can translate into McLaren's newest venture.
I've worked in a few garages before, which is a lot more of a mucky environment, which I didn't really like too much. This is a much better environment to work in. You don't smell of grease. You go home cleaner than you were before you came into work.
The company is branching out of Formula One, and for the first time ever, they aim to create and produce a range of road cars.
I'm the privileged one that's orchestrating it, but I'm certainly not the only one. I am merely a chapter in the book.
The first is the MP412C, which is being built in a special production line right next door to the company's Formula One cars.
This is the production hall, where the whole car's built from start to finish. This car doesn't really look like a car at the moment. As you can see, great big hole there, where the engine will go when it's fitted. Gearbox is also attached to the engine. There is some interior, such as the dash and some of the carpet inside. You've got a lot of the wiring going on here, which obviously has to go in first. If we're moving down to this car, you've now got some brake discs and calipers on it. These are the carbon ceramic brake discs. The car's now looking more like a car. And it opens this way. Move around to the front, you can also see that the bonnet's on and the front side panels are also on.
This new venture is a big risk. The company has already invested nearly £800 million into what is a very competitive and established industry.
It's great for engineering within the UK. To have a real brand that's exciting can really take the fight to a lot of brands around the world and supercars around the world.
At £168,500 each, the new car is clearly aiming at high-end luxury customers. Customers who just might want a piece of Formula One engineering for themselves. But it's a big gamble for the company.
I think this represents the best of world engineering, because there's definitely nowhere else in the world they're going to be able to match what our team's able to do.
This end of the building we have the Formula One team with all the inherent technologies that are needed to support it. Here are the cars that were racing just 2 days ago.
Engineering innovations from over 50 years of experience have often placed McLaren on the winning podium. But Ron knows he'll have to enjoy the same success with his new venture if it's to pay off.
I've never really embraced coming second. I've always considered coming second as being the first of the losers.
Formula One technology means the company builds some of the fastest and most sophisticated cars in the world. But mass producing this car is going to be a whole new ball game. The car started life in the hands of this man and his team, Chief Designer Frank Stephenson.
We're the guys that sit on the airplane. We don't watch the movies, we sketch. Or, we're sitting at a table in a restaurant, we're sketching on the napkin, we're sketching our hands. Designers, I think that's just a normal thing, it's just to sketch, sketch, sketch.
Car designers like Frank use all sorts of inspiration.
I personally keep some of my favorite animals in the studio. Sharks, there's a horse. Love that. I love shapes. So this is one of my favorite shapes. I get a lot of inspiration from looking at sculptures such as that. I'm never bored. Just walking down the street, you can find so many things, not just the shops. You can find, things on the sidewalk, the type of tiles, the paintings on the signs. There's always something to inspire you. So where'd my bike go? So my big interest since I was a kid was motorcycles. So this just keeps me inspired because I look at it and think, if I had done it, I probably would have ended up with something quite a bit different than that. I love that guy. That's what inspires. You think we're kids because we're allowed to have these toys in front of us. Well, that's the nature of any designer. You'll find that they have a toy shop around them. The Fokker DR1, this is my favorite plane. Good morning, Mark.
Hi, Frank.
And Frank's inspiration doesn't stop with his toys.
mean, if you look at the animal kingdom, you'll see a lot of animals that are built for speed. None of them have fat on them. They're all shrink-wrapped. I mean, you could really relate to all the energy being coiled over the rear wheels, especially because that's the driving part of our car in the back. As an animal or a cheetah, whatever, they're driving off the rear legs most of the time. And you get the undulations of the skin and the muscles actually pushing through. That's an element that we're starting to define, starting to actually bring into the design. Animals that have gone through hundreds of thousands of years of evolution are still around, still look extremely beautiful. Nobody says, that a cheetah doesn't look beautiful. It's an optimized design of what works, and therein lies the beauty of perfected design.
While computers help Frank conceptualize his designs, it's vital for him to bring his computer images to life, something he can physically touch.
Good. Now I'm taking you into the design studio. It's probably the most restricted area in the McLaren Technology Center. Very rare that people come in here, even within McLaren itself. So what I'll show you is what we actually do in here. And when you come in, you'll notice there's a very sticky pad here. That collects anything that's on your feet. So we have a very, very clean area here to work in. What you're going to see is the clay model. And contrary to popular belief, it's actually done by people who build it by hand. So mostly they're like trained sculptors who are very, very efficient at creating a physical object from a sketch. And they're masters at what they do.
McLaren are incredibly secretive when it comes to showing off their clay designs, because they are constantly experimenting with the finer shapes and contours for their cars.
To actually be here looking at the car like this is unheard of. We don't let anybody in. I mean, for us, it's a joy to come in and see the baby sort of being developed. This is almost as if it's in the womb of the mother. The advantage of clay, it's been around for the whole history of car design, is because you can actually put it on the model, and then if you put too much on, you can take it off. If you need more, you can put it on. It's almost a labor of love. I mean, you have to actually get very close to the model and feel how the transition from a hard radius goes to a softer radius. We can't do that on a computer screen. I mean, it's almost as if you can design the car blind. You don't have to see it, you have to feel it. And by feeling it, you feel if it's right or if it's not right.
The design work is obviously the first thing a customer sees. But underneath the skin, engineers have taken advantage of some of their Formula One innovations. Chief mechanic to racing legends Ayrton Senna and Alain Prost, Neil Trundle has worked with McLaren for over 4 decades.
You do 10, 15, 20 years of travelling, and then you kind of think you've seen every hotel and track. The passion doesn't go, but then you want to find a job at base, see the family. This is the F1 preparation area, where we prepare the cars for demonstrations, for testing, and also we prepare our old historic cars. This is MP41, the first carbon chassis Formula One car ever made. This is an old friend of the family.
The new car has its genesis in this Formula One car, the first to use a lightweight material borrowed from the aerospace industry, carbon fibre.
Everyone had narrow chassis, same kind of shape as this. But because of this inherently weak area here, the aluminium chassis were twisting. When we did the carbon chassis, we realised we achieved 100% stiffer chassis than had been made before. So suddenly our car was, the leading technology. Some of the other teams said that it was a fragile material, that it would shatter, but all the accidents we've had in it proved that it was up to the job. And since then, carbon chassis have got stronger and stronger and safer. But this was the start of it.
Not only was the company's carbon chassis stronger and safer, but it was a lot lighter, which meant acceleration and handling were greatly improved. And applying these design features to the new road car has obvious advantages. In the 1990s, McLaren set the land speed record for the fastest road car at the time, 240 miles per hour, in this, the XP5. The secret was the carbon fibre chassis, called a monocell. But it took 4,000 man-hours to make and cost the lion's share of the £600,000 price tag, so production numbers were limited. But through precision engineering, strength like this can now be mass-produced by the company at a much lower cost.
How do you make a composite car, which is normally unaffordable, i.e. north of
500,000 euros. How can you make the same car for 2,000 euros?
Well, that remains a closely guarded secret at McLaren. But all of the new road cars start life like this, a carbon fibre tub.
This is the very first component that goes to making the car. Without the tub, the interior doesn't have anywhere to fit. You can't put the crash structure on, you can't put the engine in, you can't put the body panels on. Everything about this tub is maximised to combine as many functions as possible into a single component. Everything has to be perfect in order for us to be able to build the car.
The tub is made away from prying eyes in a factory in Austria.
Now what I have here is a biax material, which means that on one side you have fibres running that way, and on the other side you have fibres running that way. And that's held together by the stitching that you can see here. Now, by layering this up in different ways, by using the triax material and the biax material, we can orientate the strength in the direction that we want it without adding additional weight.
Pieces of carbon fibre are layered until they form the correct shape.
This is the part of the process that I'm really excited about. It's where we actually combine the carbon fibre preforms with the resin that will hold the whole lot together and form the carbon monocell. So we have three different areas of this system. We have the preform loading section, which is what you can see behind me. We have the transfer system, which will then take the tool from this area into the press. We then have the resin injection system, and that is where all of the clever bits are done.
This machine is where a secret process injects a resin into the mould under intense pressure.
Unfortunately, I can't go into too many details because it is top secret. It's the sensitive area of the tub where we really don't want everyone to understand exactly how we make what is effectively the recipe for the tub.
This secret system is completely unique to McLaren and means a new tub can now be produced about every 4 hours.
With this process, we've reduced the number of man-hours it takes to build the chassis from 4,000 on the F1 road car down to 4 hours on the MP412C. It makes me really proud.
Once the engineers have the monocell back in the UK, the rest of the car can start to be built. The first stage of the assembly takes place at Unit 22, 2 miles from the main building.
Welcome to body assembly. So this is the start of the MP412C. This is where we get the first components, the start of the production line for us. So within this unit, we're completing that monocell prior to it going to paint.
The first things added to the tub are the crash structures, which help absorb energy in the event of an impact. Every car is hand-built and assembled by a team of engineers.
You load these longies, you load them into here with the clamps and so what. Slow it in, put the bolts in, tighten the bolts up, jobs are good and out it comes. Like. It looks all technical and tricky and that, but really it's just 3 parts there. All that just to put 3 parts on. That's what the jig's for, is to make sure they're all in the right position.
Many of the body parts are made from a special lightweight plastic material and are secured using an extremely strong adhesive. This allows them to bond plastic, carbon fibre and aluminium together, and is the same bonding technique used in the aircraft and space industry.
Better than super glue, but you've got 2 parts to it, got the orange and the yellow sides. One's a hardener. Once it's bonded, it doesn't come apart.
Once you've applied all the adhesive, then you've got to put the parts into the jig. You line it up on these 2 holes here, just line up on these 2 pins here. And then you put that in, pull the clamp round, and locks it into place.
With the body panels attached, the car is moved from jig to jig, where the various other parts are fitted into place.
It's like a big airfix kit, really, you know, it's a similar sort of thing, obviously a little bit more complicated. I mean, there's so many clamps and heaters, you just got to make sure they're all on.
With the car's outer pillars in place, the rear body upper structure is attached. Then the side panels, which attach to the lower side of the car. And with the rear panels fitted, the roof tops the list, and the body is complete. The body is then taken to a huge robot arm, which measures 356 points to make sure everything is in place to within thousandths of a millimetre.
So basically the whole process time within body assembly, from getting that carbon fibre tub to a completed monocell that you see on CMM, is a total of 495 minutes. Our main aim within the facility over in MPC will be to get one car out every 45 minutes.
Currently, the new car is assembled within 2 separate buildings. But to streamline the process, a new facility is being built to house everything under one roof. And if the company is to make this a viable project, they need to ramp up production from 10 to over 80 cars a week.
One of the biggest challenges when you're focused on trying to build a supercar is, without question, paint quality.
Painting cars is often an automated process, but here, even this is done by hand. It's going to take over 12 hours from the body first entering the paint shop until it leaves. And in this facility, attention to detail is everything.
Yeah, we keep doing it till it's perfect, until every surface on this car is flat. Until all the imperfections are sorted, we won't let it go through. It can be tough, but yeah, we don't stop till we get it right.
You're just fighting against dust, dirt, sweat, water. That's why we wear gloves, you know, sweat, everything that can contaminate paint, no matter how small it is, will contaminate it.
We all take a lot of pride in making sure it is perfect, and some, you know.
After a day's work, you can't wait to jump in the shower or bath, definitely. Plenty of deodorant, but the correct stuff, because some deodorants can contaminate the paintwork, so...
Some hair gels do affect the paint as well, but with some people, I don't have to worry about
that. No, I don't have to worry about that, no. Thank you, Jill.
Behind the booths, paint mixer David Carter has worked in the trade for over 30 years.
This is called the paint kitchen because you make stuff and create masterpieces, if you like. Different tinters and ceramics, metallics, straight colours, reds, greens, to make all colours of the rainbow and sun. So I would imagine with these tinters we can reproduce any colour that you could ever imagine.
Today, Dave is hand mixing Volcano Orange.
Gently stir it in, try not to splash any out or onto the side. And obviously with the special colours, the extra sparkle as well. Sometimes it may just sit on the bottom there, and using a clear cup you can see those last bits in there. You don't want to get to a point where you pour it out and half the ingredients are still stuck to the side of the bottom.
But before the paint goes on, there's one last job to do.
Basically, this is an anti-static gun. So we pass it over the vehicle and it takes away the static electricity, which again draws particles to the body and will end up as dirt inclusion.
Finally, the paint can be applied.
This is a pressure pot system where all the paint is in a pot at the front there. The pot is charged and then paint is fed through the line at a constant rate.
The cars come in a variety of colours, but whatever the customer chooses, they still have to pass an eagle eye.
Now, my name's Claude, but my nickname within the business is either Hawkeye or the Master. If I see something, I have to pull it up. I just can't leave it. I am fussy. I have to be with these sort of jobs. You know, customers looking for perfection, and I have to deliver that. I'm looking through the centre of the door. I'm looking basically for flat marks, which will be where I've actually DA'd the panel. I'm just going to look through there to see if the actual panel is uniform all the way through. going to be one of those days where this panel is going to be spot on.
Once painted, the car is ready for the rest of the assembly process. First is the electrics, which come in something called a loom.
In this box is the wiring loom for the car in its entirety.
With over 2 kilometres of cable and 2,000 individual circuits, it takes a team of 3 men to put it in place.
The way we put the loom in is operator 1 sits in the middle and feeds the loom from the inside of the car to the rear, and then feeds it to me, operator 3, from the inside of the car to the front.
I am literally the middleman.
One feeds and one tugs.
Your knees and your back, they tend to hurt after about 10-15 minutes, but it's not too much, get used to it.
I run it across the back and then make sure it's not twisted, and then once I've made sure it's not twisted, there's a fir tree up here which I plug in, and then I drop it through this gap here, work out which wires go where.
It's not too bad once you've done it a few times. You get the hang of it, you get to know which plugs go which side the wiring loom's got to go in. It's the nervous system, the veins. Without a loom, nothing's going to work.
You have to be careful of the plugs, because they can break easily if you're a bit ham-fisted with it. But other than that, it's all right. We just work all right as a team. Everyone sort of mucks in and you just get the job done, really. Help each other out where needed.
It's all compact. It's like moving a stick and without breaking it. It's just a bit hard to move, get into place, try and get the plugs coming out in the right directions. And basically just getting it sitting nice so you can put the rest of the interior on top of it without wires bulging out everywhere. It can be tricky.
The team fit out a loom in just 2 hours, but to hit the targets for the future, they'll be trying to do this job in 45 minutes, which means more workers and more space. Since March 2010, this purpose-built production line has emerged on the landscape right next to the main building for exactly that reason. Operations Director Alan Foster is in charge of the build.
It's really only when you stand up on the hill that you actually see the true scale of the production centre. All you can see is probably the top 1/3. I mean, there's a basement underneath here.
For McLaren to succeed with their ambitious business plan and recoup their costs, the new facility has to increase production to at least 2,000 cars a year.
So what you've got here is general assembly. It's just a larger version of what we saw previously in the technology centre. It's a row of 18 cars on the right-hand side, 14 cars on the left-hand side that come back towards us before they move off into completion. When you open this door, you'll walk onto the production floor of McLaren Automotive. This is the new production centre for the 12C. So we've got body construction, which is just to the right of me. Just behind the wall is the new paint shop. And then, as I say, we've got general assembly and then final vehicle and line certification for the cars before they go out to the customers. You can create a facility to do today's job, but in 5 years' time, that facility possibly won't be able to do what you want to do. So then you're into large structural changes, equipment changes. Very expensive. So what we try to do is maintain openness, and there's only really 3 hard points in the complete facility: the rolling road, the monsoon and the paint shop. Everything else is completely interchangeable at almost within a week's notice.
The carbon fibre monocell tub is not the only F1 innovation to cascade into the new car. They've also included a technology that was actually banned from Formula One.
We've introduced some very innovative ideas over the years. Brake steer was our secret weapon. Brake steer was a 4th pedal inside the cockpit. So conventionally you have 3 pedals, the throttle, the brake and the clutch. We introduced a 4th pedal on the left, and in the corner the driver could squeeze that pedal and it biased the drive to the outside wheel and enhanced the turning of the car. Well, we kept it a secret for, I think, about 6 races, and then a journalist put his camera down inside the car and he got a picture of that 4th pedal and the secret was out. But it's a great method of improving the cornering.
Neil's car had an extra pedal, but the 12C does this all via computer. At this speed, the car would normally follow this line, but using brake steer allows it to follow this line. holding the apex of the corner and killing any understeer. By taking into account the speed and steering angle, the computer works out the correct trajectory. Located in the front luggage compartment, it sends a signal to the inside rear brake when cornering, allowing the car to effectively pivot around the desired path.
So all you feel is like someone's grabbed hold of a pole on the inside of the corner and you're swinging around it, so it just buys you massive cornering performance without having to compromise high-speed stability, and so we've got the best of both worlds.
But it's not just the brake steer that helps with handling. The braking system on the 12C means it can come to a complete stop from 124 miles an hour in just 5 seconds. Making sure the car will stop quickly and safely is a big responsibility, and today it falls to trainee Rachel, who's about to fit the brakes.
I've taken the brakes apart before, I've taken the calipers off and a couple of the discs, but I haven't done it to process.
On EPP.
Cool.
As an apprentice, Rachel is under the watchful eye of a more experienced assembly engineer.
The torque values are all set for each bolt and for whatever material it's going into. It just ensures that it's not going to come undone and it's at the highest tightness sort of thing that the car can go for. Now it's going to be checked by the quality engineers.
Is that a quality man?
He is a quality man.
I have to make sure that their bolts are done up to a minimum, within minimum tolerance. Because it's an EPP, it's a safety critical part.
The parking brake has to be doubly checked just to ensure that it is at the right torque.
354, all good.
Cool. Yeah, that's probably about the size of the wheel of my car, let alone just the disc. The disc has to sit completely flush on the hub, otherwise it can cause juddering when the car's braking. You want to stop pretty quickly from 150, so you don't want it juddering when you're trying to stop. It's all done hydraulically, so the fluid comes in here, and when you put your foot on the brake pedal, pushes the fluid round the system, and then that'll push the piston closed, which will clamp the 2 pads onto the disc. That's sort of a quick explanation, really.
Just make sure the holes are lined up with the disc before you start. And the bolt in. That's it, yeah.
I've found that having small hands is quite an advantage, as a lot of the guys are ended up coming around here and going, oh, can you just get that for me, or can you just plug that in, or can't reach it. So it's quite good in that respect.
Yeah, I worked my way up through apprenticeship, and then it's nice to see young people like Rachel coming through and really doing good stuff, you know, and it'd be nice to see them work their way up as well. Doing the brakes on the car is quite tricky. You've got to make sure everything's aligned and sitting right on the car, and she does it perfectly, really.
Hopefully when I've worked out how to do it today, I'll be a lot more confident in changing any of the brakes, and it'll be a lot easier when a job comes in. Hopefully get it done a lot quicker. That's job done for the brakes.
While McLaren have been adapting their F1 technology for many things, it's different for the engine. The car's 3.8-litre twin-turbo V8 is the first engine the company has ever designed themselves. A V8 is basically 2 4-stroke engines bolted together with a single crank. A 4-stroke engine works by allowing air and fuel to mix in the cylinder. At the first stroke, a vacuum is created. At the second stroke, all valves close, allowing the pistons to compress the air and fuel mixture, ready for detonation by the spark plug. The explosion forces the piston down, transferring its energy to the crankshaft, which in turn powers the flywheel, the gears, and the wheels. The last upward movement of the piston forces open the exhaust valve, releasing used gases. The pistons are just one of the 1,100 handmade parts in the engine, and they're made at a specialist factory in Basingstoke. It's the job of Sean Ward to turn these blocks of aluminium called billets into pistons.
I've only been in engineering 10.5 years. Before that, I spent 9 years as a lorry driver, and before that, I was 12 years serving King and Queen and Country, I should say, not King and Country. I'm not that old. The lube we use is a graphite-based lube, sprayed on with a carrier, which is GTX.
The billet is first heated to 460 degrees C, or gas mark 21, to make the alloy malleable enough for Sean to forge.
And the lube we use to paint on the brush is also graphite based, and it just stops everything from sticking onto the tool.
The hydraulic forge press has squeezed up with the equivalent weight of 88 elephants onto the preheated aluminium billet, creating the basic shape of the underside of the piston.
Quick visual check, yep, everything's okay. It's like baking a cake, this job. You've got to get the temperatures right, you've got to get the ingredients right, otherwise you don't get no cake. In here, we have enough pistons for 29 engines with a few left over. So this week, I've produced enough pistons for 60 cars. I don't normally look at it in that perspective, so I'm quite chuffed with that.
But when production ramps up in the new building, Sean will need to build nearly double the amount of pistons.
Basically, this is the what we call the 600 oven. It's the main heat treat quench oven. When I can get it through the gate. It's a bit of a tight squeeze and they're quite heavy.
To optimise the piston's basic metallic structure, the forgings are cooked again at 485 degrees C for 10 hours. The parts are then dropped into a secret solution. This type of alloy increases in strength as it cools. Then they're cleaned through an acid line, removing the graphite lubricant that was used in the forging process.
It can burn you, so it's best to wear your apron, long gloves and the visor.
They're placed in acid for 4 minutes and then washed off before they go into another of Sean's special solutions.
In here we have tiger juice. Put it this way, if I was to put some on the concrete, we'd see bubbling and it would disappear down towards the centre of the earth. It is like wash it up, but don't tell the wife. Otherwise she'll have me doing it at home as well. As you can see, before acid, after acid. Now we come to the fun bit. Pushing this into the aging oven, something you have to put your back into. Close the door. Check the temperature. 185, job done.
At full speed, each piston travels up and down 140 times a second. So precision engineering is essential. The piston goes through a process of further aging, milling and machining before being put together.
So this is where we actually put the piston together with the piston rings, gudgeon pin and all the pins that go with it. And this is ready just to be packed up in the packaging and actually sent to the engine builder. So we have a full set of engine pistons and a set of engine liners. The engine liner will go in the block, the piston will get connected and then assembled together. And then that basically is what you've got, the heart of a supercar. Then you turn the key, 170 mile an hour and away you go.
Just up the road at a specialist engine manufacturer, the rest of the parts are assembled, with the pistons taking their place in the engine head. But this company doesn't just build the engine, they also create what it will actually sound like.
My name's Matt Maunder. My job is basically to make cars go vroom vroom as nicely as possible. That's my job.
You might think the sound of the engine is just a byproduct of the moving mechanical parts, but it's actually been designed by an engineer.
If you've paid extra money for a sports car, you really want to have something that's going to make the hairs on the back of your neck stand up, a bit more vroom vroom.
And when it comes to how a car should sound, this man is obsessed.
This is the Ricardo car park. We're going to have a look round, see what cars we can see. That's a Japanese car. That's probably pretty quiet, I should think, that one. BMW, that'll be tuned up for the American market a little bit more rumbly. That's a Lotus Esprit, isn't it? I think that's a turbo engine. And yeah, they're pretty much a high-speed European-style screamer, that one. And they're all four-cylinder cars, and they're all a bit dull. British people definitely like a bit more exhaust sound coming out of their car. I guess it's kind of throwback to sort of motor racing history that we've got in this country. Yeah, Americans tend to like more of a burbly V8 sound. Italian cars tend to be a bit kind of shiny, pointy-shoed, you know, and a bit girly sometimes, but they kind of squeal beautifully, I think, that's what Italian cars do. Japanese don't seem to care about the sound of their cars, so they're quite happy to have something that's just quiet and innocuous. I mean, there's a Honda there, but maybe they're too polite to have a raunchy car sound. That's what it is. We did a study that showed that sound made up basically half of the feeling of sportiness. You know? So part of it is the feeling of acceleration being pushed back into the chair, but the other part is the oral onslaught you get coming to your ears from the engine.
McLaren's brief was concise.
They wanted it to sound really extreme as a sports car, in fact. So first part of the work we did actually was to try and find out what that meant. So we've got here the sort of the most boring sounds. So McLaren thought this one was dull, normal and weak, no character, like a Kylie Minogue pop tune, you know. And then this one is the kind of Kanye West, very well produced, smooth, precise, pleasant. I quite like that one. Whereas this one is a bit more extreme, you know, a bit more rough around the edges, a bit of a Dizzy Rascal, that one. Welcome to the least echoey room in the world. Basically, these wedges are made out of absorbent foam, and they actually absorb the sound. But because of the shape of the wedges, as the sound comes in, it bounces further into the cracks. So it also hits the foam multiple times and never comes out again. That's the idea. Which is the same effect as you would get if you were outside on an open field, where the sound just travels away and there's nothing to reflect it back again towards you. And that's why it sounds a bit strange. So this is our workhorse car, which we've been using for the development of the sound of the car. The business end is at the back, of course.
The 12C has a relatively small 3.8-litre engine. To get the power associated with a supercar, engineers have bolted on twin turbochargers, which force more air into the cylinders, creating an even higher combustion level.
The turbocharger actually cuts down a lot of the sound that comes out of the exhaust pipes, which isn't really good for a sports car. We want to have as much noise as we can coming out of there and tune to a nice sound as well. So one of the key things we've had to do on this car is to tune the exhaust system to match up with the turbochargers so that we can get the right kind of sound out of the back of the car. The engine is like the breathing, spitting heart of the car, and then it's got two saxophones on the back of it. And by tuning the exhaust system to get the right kind of mixing between the different cylinders, that gives us the Metallica sound that we were looking for earlier on. So that kind of got a bit of oomph to it, hasn't it, that? I really like that. I can really say, like, I did that. I made that car sound like this, and that just makes me feel quite proud.
How do you feel the sound is?
I like it.
Yeah?
In sports mode.
Really? I can't hear it.
You put it in track, it's good. Oh, he's going. See ya.
Give it some so I can hear what it sounds like from here. Right, just here. Okay, we're on the runway. It's slippery as hell. 4,000 RPM now. And now I'm dumped
Professional racing drivers might have pushed the new car to its limit, but most customers won't be driving it on a racetrack. It's a road car, so how it handles on different surfaces all around the world is a top priority.
We use these secret proving grounds for two reasons. One is confidentiality, so that we can develop our product to a level where we're happy to sell it. So, if we're going to make any mistakes, we want to make them in relative secrecy. The second reason that we come to proving grounds is that you can pretty much do within reason what you want with the car in terms of speeds and how fast you go around corners, and obviously you can't do that on the public road.
This kind of testing allows them to find and fix faults before customers do, and they use specially built roads to do it.
So this surface is a specifically designed, badly maintained road. It will expose any squeaks and rattles. We're now going on to the Belgian pavé surfaces. So these generally give shorter wavelength inputs into the car and expose any kind of secondary ride issues that it might have, or if anything is going to drop off the car, it would be here. It does rattle you around a little bit driving over these things. These are the washboard surfaces, which are quite harsh and not dissimilar to sort of cat's eyes on a motorway, but more severe. It's quite difficult with a sports car that needs to be stiff in the corners to also be compliant on the bumps.
The new car has some very clever engineering, which should allow it to cope with most road conditions. At each corner of it, there are independent spring and hydraulic dampers. Fluid-filled chambers are linked to each other. As high pressure meets high pressure under roll, the chassis stiffens. But to have a more comfortable ride on a badly maintained road, hydraulic lines connect the front and back, allowing each wheel to operate independently.
The car has got a number of discrete suspension settings which allow it to become moderately firm on rough surfaces, but at the flick of a switch you can turn it into something that's also very responsive on racetrack kind of environments. So Check and Hide, I think, is probably the best description you can give.
The team work with a fleet of over 50 prototypes, and one of the oldest is maintained by engineers like Richard Yeo.
It's a workhorse basically, so it's just kept running, patched up, and it does its job. Temperatures coming out of the exhaust are approximately about 800 degrees, so we've seen problems with the bumpers melting before, so it's just a way of bypassing that and just carrying on.
When the team discover problems like the melting bumpers, tweaks and adjustments can be fed back to base to fix them.
This car does look proper Mad Max, but I can assure you all the equipment in the car is top notch and is the highest spec that you can get. As you can see, it's quite different to a production car that you would see on the line. We run quite a lot of data logging, 2 screens here so the driver can see everything that's going on with the engine, and also all these switches here are bespoke to nearly all the test cars. So you have here fire extinguisher armed, engine kill, battery kill, and this will be for just recording their laps during the durability cycle. And on the rear shelf is where the data logging computer normally sits.
Having worked on this project for nearly 5 years, Richard has become rather attached to this prototype.
Yes, my baby. I've worked with it for a long time now.
What will happen to it eventually?
It's going to get crushed. Yeah, it will die eventually, this car. Although it keeps refusing to.
The first time I went on this curve, I thought I was going to crash.
To expose any weakness from high mileage wear and tear, the team put the car through the kind of stresses it would accumulate over several years.
We're just doing a couple of maintenance checks before we hand it over to the nighttime driver. Yeah, we do sometimes work 24 hours if the job needs to be done. We can't be holding up production, so sometimes it's imperative that we keep going. Hopefully I'll get home before my girlfriend goes to sleep.
The testing program is not a 9-to-5 job. Continuously on the road, 24 hours a day, 7 days a week, the car can accumulate more than 50,000 kilometres a month. Tonight is the job of Rob to do the first 3-hour night shift.
If we ran
just during the day, we'd get half the amount done, and in such a short period of time, we managed to gain a lot of information. I suppose a lot of us are just a bit frustrated Formula 1 drivers. Didn't get that opportunity, so we'll keep on pushing and pretending.
Tests like this are the only way McLaren can know how the car will last during its lifetime. Back at the assembly line, the new cars are about to have their engines fitted. To save on weight and space, the engine and all its ancillaries have been packed extremely tight. The assembly engineers must take utmost care when bringing the car down, guiding everything into place and making sure nothing clashes. Bolts are put in underneath the frame and the engine is fixed in place. On other stations, the interiors, final body panels and wheels are also fitted. Currently, around 10 cars are rolling off the production line every week. But Operations Director Alan Foster will need to quadruple this output to meet the initial demands for delivery, and is looking forward to moving into the new McLaren Production Centre, or MPC for short.
It's getting very busy. We're only about 2 weeks away from the planned move now to MPC, and frankly, we need to get into the new building very, very quickly now.
My goodness, everywhere you see there are car parks. I think you could call that a pretty congested end of paint facility.
Obviously we're limited for space here. We've only got 5 spray booths, so therefore we can't get as much output as we'd like. So the new facility should be speed things up a great deal.
As you can see, it's like a car park at the moment.
McLaren need to start selling these cars as soon as possible in order to recoup their multi-million-pound investment.
Bottom line is we need to move cars, so I want the transition from this pre-production facility into the production facility as smooth as possible.
Despite the mounting pressure, the company remains a stickler for detail and continues with its drive for perfection.
The casters have arrived and the suppliers changed the colour of the rubber, and that's not acceptable. It's not the colour that I ordered. So it's going back and they're going to change them. That times 400 throughout the build facility would just look too dark against the background that we've developed within MPC. The colour it should be matches the cabinet and the walls in this room. As you can see, a couple of shades too dark.
With the new casters in the post, it's now just weeks before McLaren need to start delivering cars to customers, and today is the day of the big move.
My plan is we will take them over in groups of 20 so that we can give them an induction.
Yeah.
Kind of show them station locations, etc. Cars will be going after lunch from here. By the end of play today, I expect all of my team to be out of their lockers and go to work in there tomorrow morning. Okay, thank you very much, guys.
It's taken 14 months to build, and Alan realises the hard part still lies ahead.
It is quite a massive move. To think that you're going to move a whole factory in less than 8 hours is quite insane, really.
Body assembly and the paint teams are the first to move in, and Executive Chairman Ron Dennis is on one of his frequent inspections.
What we have here is our assembly hall for the 12-seat, rapidly nearing completion. The side of the factory is dedicated to the assembly of the monocell and crash structures, and then into the paint facilities.
In the old building, 5 booths painting body parts meant around 3 cars a day could be finished. But in the new facility, this can be increased tenfold.
The whole objective of having the level of detail that we strive for is to get the perfection in the finished product. It's sort of like a second home to me. You know, I have a sense of order, an attention to detail, a desire to do things really well. And time will tell whether the approach that we've taken to producing this very unique car has worked or not.
If all goes according to plan, then this new facility will enable the company to add 300 new jobs to its workforce and produce 80 cars a week to help them meet the orders they already have. and the targets for future sales. But now it's time to unveil the new car at the new dealership in London's Knightsbridge.
In the end, I think it's all about selling cars to real people, and this is where it starts.
I think it looks fantastic. It looks absolutely amazing.
It's a big night. We've been looking forward to this for a long, long time. Personally, it's like going to the hospital to see your baby finally being born and brought out into the daylight.
I like the way how the doors open as well. It's really cool.
Big smile. When the doors open for business, first customer that comes through the door will be told, "I'm very sorry, it's a 2.5 year waiting list," which in this world and this market is a great thing to hear.
I've ordered 3, obviously.
This is the point that we've all been working for the past 4 or 5 years, so very, very, very excited. Difficult to put into words.
The phrase that comes to mind is "I'm clearly in" on this one.
That's when you know you've got it right, when everybody looks at it and says, you know, I wish I could have something like that.
There may be glitz and glamour at the launch, but for the engineers, there's an important message to be understood.
People say manufacturing's been dying to death in this country, but anything but. Manufacturing's getting busier and busier. We're a nation of inventors.
We've had a long history of being the best at what we do, and basically, I'm just trying to carry it on.
There comes a point where we need to share it and take it, whatever comes, be it critical or praise. It will go to the market. The first car was delivered. That is the first car. The dealers will receive all of their cars by the end of the month. We will ramp production to 4,000 a year over the course of the next 4 years. We are going to be criticised, but I can tell you we are going to succeed. Thank you very much.
With the creation of their new car and the facility it's built in, McLaren know the stakes are high.
The place is so big, it's amazing. I can't believe how clean and white and sparkling, brand new everything is.
I said to one of the guys today, you know, if you went down to the hospital down the road with your arm car, you'd rather be in here having it tended to than down there.
I made that car sound like this, and that just made me feel quite proud.
You'll see it driving down the road and everyone's going to be like, yeah, my friend Terry fitted that car.
We've made cars in Britain for decades, and although some argue we have passed our heyday, taken as a whole, the automotive industry still accounts for around 10% of all UK exports in a highly competitive international market.
You can feel the passion in this place. There's people that have been here a long time, and we're not just here for the money.
McLaren's new car may be the latest, but it certainly won't be the last. In the next programme, we meet the engineers in one of Britain's most high-tech industries and discover how to build a satellite. From sketch to structure, see how designs come to life by visiting bbc.co.uk/how-to-build and follow the links to the Open University.
Next this evening, stay with us for a question of survival and medicine on the front line with Michael Mosley.